Hi everyone, section 7.1, learning about the world through surveys. Okay, so we need a couple of definitions first. The population is the group of either objects or people that we want to study. So this is what we want to make estimates of, or make estimates about. And the parameter is the numerical value describing some characteristic of the population. Okay, so an important note here is that for chapters 7 and 8, we are going to be focusing specifically on what we call population proportions. Proportions being another word for percents. So specifically, everything in chapters 7 and 8, we are going to be trying to answer questions about some sort of a percent of our population. What percentage of Americans are left-handed, or what percentage of Heartland students take more than 15 credit hours. So every question we answer in these chapters are going to deal with these percents. A census measures every member of the population. So these can only be good for small populations. A true census is actually very difficult to achieve, so we almost always do the next thing, which is take a sample. A sample is a collection of people or objects that are taken from your population. So usually the population is too big to actually measure every single person or object in it. So instead we're going to take a sample, and the number that comes from our sample is called a statistic. So it's the numerical characteristic of that sample. We use this to estimate the parameters, and because of that, it's sometimes also called an estimator. So what's important here are these matchups. The fact that a population is a group that we're trying to estimate something about, and the value we give to that is called a parameter. They both start with P. The population has a parameter, but then we will take a sample, and the number that comes back from that is actually what we call a statistic. So it is nice that at least they start with the same letter. That can help you keep them organized. Okay, so then we've got some statistics versus parameters down here in this box. And what's important mostly is this bottom row right here. This is the chapter 7 and 8 focus. They are the proportions, and this is their notation. So P is what we call that population proportion, the percentage about the whole population that we're trying to figure something out about. That's what we call P. And then when we take a sample and we actually calculate the percent that comes back from just that sample, we give that the notation P hat. So it's P with a little hat on top. Okay, so for our first example here, we've got in February 2014, the Pew Research Center surveyed 1,428 adults in the U.S. who were married or in a committed relationship, and they found that 25% of cell phone owners felt that their spouse or partner was distracted by his or her cell phone when they were together. Okay, so we have knowns, which are English letters, and we have unknowns, which are Greek letters. So the things that we can know are what happens in our sample. So in the sample, what is the sample? The sample was those 1,428 U.S. cell phone users in some kind of a relationship. That was the sample that we took. So then the statistic, the number that came back from that sample, in this case was the percent of those guys. We know this value. This value is known to be 25%, who feel like their partner is distracted. Okay, so again, the sample brings back a statistic for us. Now we have some unknowns. The unknowns are going to be all the population, the whole population that we're trying to make a estimate about is all U.S. cell phone users in relationships. I don't think I can ever truly know exactly how many people that is. Then the number, again, that we are trying to estimate about this population is the percent of those people who feel their partner is distracted. So again, this one is P, the parameter that we don't know, this percent that we're trying to estimate. And this one is P hat. This is the percent that actually comes back that we do know. Okay, so unfortunately, it is definitely much easier to conduct a bad survey than it is a good survey. And one of the many ways we can reach a wrong conclusion is to use a survey method that is biased. Biased simply means that it's going to produce an untrue value. So there's 4 different types of bias that we're going to talk about. First one's called sampling bias. This results from taking a sample that does not truly represent the whole population. So an example of this might be only sampling one neighborhood in a city. In a large city. Different neighborhoods are going to maybe have different makeups of type of people, and maybe a single neighborhood doesn't represent all of the different thoughts and ideas of the entire city. Okay, then we have what's called measurement bias. Measurement bias comes from asking questions that do not produce true answers, and this can enter your surveys in lots of ways. One way is embarrassing questions. Or it doesn't necessarily have to be embarrassing, but just personal information. Or it could just be simply due to poor wording. So maybe you've read some questions, test questions or survey questions before where it seems as though they're asking 2 questions and you're only allowed to say yes or no. And you're like, well, I kind of feel yes about one part and no about the other part, so I don't really know how to answer this. So that could definitely be one way that surveys don't give back accurate information. Then we have voluntary response bias. That's when sample members self-select. So if you can choose whether you want to take part in the survey or not, what usually happens is it's usually only those who feel strongly one way or another that care to participate. You don't get a lot of the kind of in the middle feelings. You usually get something that's very kind of swayed one way or the other of the spectrum. And then of course you could have non-response bias. So that occurs when people don't participate at all. That could come from things like mailed or emailed surveys, phone calls, etc. Have you ever got a survey via email and you've just said, delete, I don't have time for that? And so then your opinions are completely left out of that survey. So when people choose not to participate, certainly that can create some bias. Okay, the next definition is not a type of bias, but it leads to bias. It's called a convenience sample. A convenience sample is made up of easy to reach people. So of course it's convenient. This happens then a lot. We perform these a lot. So one example here might be like sampling people in your class. It's easy to do. It's easy a lot of times to actually ask the students who are right around you. But it's usually what this one leads to is that sampling bias. Because usually that sample then isn't representative of the whole population. Your class does not represent all of Heartland. it represents just one specific type of student. In this case, it might be an online student. Well, that doesn't represent all of Heartland. Or if you are in a night class, maybe your sample represents night class students, but not anyone during the daytime. So that's what it usually leads to. Okay, so it seems like there's an awful lot of types of bias. So how can we limit the bias in our surveys? Really only one thing works, and that is to take a random sample. It's going to be our key phrase for the rest of the semester. So there's what we call a simple random sample, or you might see it denoted SMS. That's when you draw subjects from your population at random, of course, and without replacement, so that each member has an equal chance of being chosen. Well, why do we want to do it without replacement? Well, with replacement means that you could select the same person multiple times, and that could definitely bias your survey. Then if you end up asking accidentally the same person many times, then you're going to get the same answer back many times, and that's going to pull your results in one direction. So you want to do it without replacement so that everyone can only be selected once, and then they're out of the pool.